In this session, I'll be continuing talking about safety in other chapters of the book. So there are three key words that I'll be talking about: caution, warning, and danger. So cautions are things that you need to be mindful of. Warning are steps that you can possibly injure yourself, and dangers are very, very hazardous. Okay, so the first caution is when you're doing the LED design of experiment, be careful not to connect the red and the black probes together on the same side of the wire. So in this experiment, you do not want to have the red and the black on one side of the wire because that'll short circuit the battery. The next case of a caution is when you're doing circuits 1 project. And so I talked about this in the earlier safety videos. When you're measuring current, you need to disconnect your circuit in order to prevent the fuse from being blown out. The next caution actually no longer applies because we don't use electrolytic capacitors, but just for completeness, I'll talk about it. So there are certain types of capacitors for which the polarity is important. You must connect the positive side to the positive leg of the LED of the capacitor. Otherwise, you have a risk of it exploding. So the capacitors are polarized, meaning that the long leg must go to the positive side, and the side labeled with the minus or minus sign must go on the negative side. If you wire it incorrectly, there's a slight chance that the capacitor will explode. But we don't use these electrolytic capacitors anymore. We instead use ceramic capacitors. So it's preferable to use the ceramic ones rather than electrolytic. The next caution is when you're building your FM circuit, transmitter circuit, in the final step, you're going to be adjusting this trim cap to be able to tune the frequency of your FM transmitter across the FM band. Now, this trim cap is very, very sensitive, so you actually only need about a 10% of a single turn to cover the entire FM band. So make very, very small steps when you're tuning, something like 5 or 10 degrees at most, and don't cover more than one full turn. If you turn it too much, there's a chance that the capacitor gets damaged. Okay, the next caution comes in when you're working with the LED calculator circuit. So you'll be building this LED calculator circuit by soldering the pins onto the battery onto this test circuit board, and then you're going to be connecting it to a breadboard. So the gate, this gate that you're working with, so an AND gate or an OR gate, it's electrostatic sensitive, and so you always want to hold these types of parts by the plastic part rather than the metal leads. If you hold them with the metal leads and you happen to have walked on a carpet and you've built up static electricity, you can damage the gate and it will no longer work. The second major caution is that you should never send the voltage of an output gate, i.e. never connect 5 volts or ground to the output of another gate. So keeping in mind with gates, gates have an input. So in this case, pin 1 and pin 2 are the inputs. Pin 3 is the output. You don't want to connect 5 volts or ground to pin 3 or to pin 6 or pin 8 or pin 11. Those are the outputs of this circuit, and you cannot set the voltage at the output. You can only set voltages at the input. So you don't want to connect the output, for example, of gate 1 to the output of gate 2. You don't want those in the same column with a jumper wire because that will blow out the chip. So this shorts the circuits and burns out the chip. The output of a gate, for example, pin 3, 6, 8, or 11, can only be connected to either the LED display circuit. So these pins that are the input for this circuit that connect to the LED, or they can be fed into the inputs of another gate. So I can take the output of gate 1, like pin 3, and I can connect it to pin 4, which is the input of gate 2. And you never also want to feed the output, so this is a separate issue, but you don't want to feed the output of a gate back into its input. So don't take the output pin 3 and connect it into pin 1. That will create a feedback loop, and it could potentially cause damage to the chip. Okay, so when you're also when you're building the LED calculator, you should disconnect the battery and then swap the gate. So you don't want to have the gate being disconnected or taken out of your circuit or put into your circuit with the battery in place. You want the power off, then you adjust your circuit, then you put the power back on after you're done. For the power and energy section, you'll be working with a battery and flowing currents through this loop, and this is going to form a motor. So keeping in mind that if you have a 1.5 volt AA battery or AAA battery, I think you're going to use a AA battery, and the loop, based on its length, it only has about 0.3 ohms of resistance. That means that you'll have 1.5 volts divided by 0.3 ohms, or 5 amps of current. This is a huge amount of current. Now, in practice, the battery itself has some internal resistance, and so that's going to limit the current to about 1 or 2 amps. Nevertheless, if you can connect this in this configuration, the battery will drain in about an hour. Now, C&D batteries, they're bigger, they have more charge, or they have more current that they can supply current for a longer period of time. And so they can supply for a few hours. Now, with this amount of current, the circuit and the battery are going to get hot. So do not leave your motor unattended and connected. You want to disconnect your motor at the end of the testing. Okay, so we've talked about all of the cautions. So now let me go talk about the warnings. Okay, so the first warning is when you're building your FM transmitter circuit, so this circuit, and you're soldering it. So warning is to do not plug in the battery until you're completely done, number one. And number two, make sure that someone has checked it. So ideally, a lab assistant or instructor will check your circuit to make sure that all of your wires on the back are properly trimmed and that you don't have any short circuits. So don't plug in the battery until you're done and your circuit has been checked. A very common thing when people are soldering their circuit is that on the backside, some of the wires are still touching each other after you've soldered it. So you have to trim the backside. The other thing that you have to do, and the reason you don't trim it until the very end, is if you have something in the wrong spot, you can unsolder it before you trim it and put it into the correct spot. Okay, and then the last warning, it's coming back to the generator, so the power and energy section. So when you're working with the magnets, these magnets are very, very strong. And so they snap together very easily. So be careful how you're placing your fingers near these magnets so that you don't get them pinched. Okay, so now let's talk about the dangers. So these are extremely important things to be mindful of. So most of the dangers are going to come in the section on chapter 16 where you're fabricating your solar cells. So this is only an in-person at University of Illinois type activity, or if you somehow have access to the necessary equipment in clean room and fume hood and spinners and so forth. So this will likely not apply, like you most likely will not do this project as part of your STEM club. So the dangers that that happen are, so these are things that if you do it incorrectly, they can cause severe permanent health damages or health damage to yourself. So when you're working with a chemical known as buffered oxide etchant, this stuff eats through your bones, unfortunately. So this step can only be done by a trained user inside the clean room for working with this buffered oxide etchant. And if you happen to get some on your skin, there's special calcium gels that are applied to prevent permanent damage. But you're wearing gloves, you're wearing a full bunny suit, and you're being extremely cautious when you're working with this sort of chemical. The second hazard that comes in is when you're working with the oxidation step. And so in the oxidation step, you're loading your sample into an oven that goes up, that starts off. So the starting point is that the oven is at 400 degrees Celsius, which is 752 Fahrenheit. When it's being used, the cell will go up to over 1,000 degrees Celsius. So this is extremely, extremely hot. And then the last danger, at least in these steps, is again, there's another step that uses this buffered oxide etchant, and so it also attacks glass. So this needs to be done by a trained user. The next one, so this is still in chapter 16. This is talking about making a solar cell using this attaching of copper strips using this special solder paste. The solder paste is unlike the solder that you work with in your soldering irons. This paste is a large area. It can cover large areas, and then you typically will heat it in an oven. So this step, it produces a lot of fumes. And so this should only be done inside a fume hood. Like even in a well ventilated area, you don't want to put this on a hot plate and try to melt the solder paste. Instead, this needs to be done in a clean room. Okay. Again, still in chapter 16. So this is fabricating a solar cell using a chemical known as Tollens reagent. This Tollens reagent is an interesting chemical in that it allows you to make this solar cell in a very simple step. However, the Tollens reagent must be prepared immediately before use, and it must be disposed of properly via an acidification step within a few hours. Otherwise, if you just leave it, it starts to precipitate, and these precipitates can be explosive. This is one that will apply to the STEM clubs. So when you're working with the laser levels, do not look into the laser beam directly. It can do damage to the eye. Now, fortunately, this laser is in the red part of the spectrum, and so it's visible. So you can tell that you're looking into the laser. In my line of research, I work with lasers in the infrared part of the spectrum, and there you can't actually see the laser, but it can still do damage. So as a general safety practice, as good habits, you must always be mindful of where the laser beam is going and make sure that it's aimed in a way that it's not towards others. This project is if you're working with a voltage controlled motor. So in the advanced activities for the STEM club, or if you're on a robotics team, you have to think about what happens with a spinning motor. So like in your toy cars and so forth. So when you're working with motors, you must tie your hair back. You don't want to get your hair or loose jewelry or dangling sweater strings or other loose clothing caught up in these motors. Depending on the type of motor, they spin really fast, and they can pose either like a strangulation hazard, or they can essentially pull your head into the spinning motor. There was a very sad story of a student who was doing research at, I believe it was Yale, who was working with a lathe. So a lathe is a spinning machining tool, and her hair was not tied back, and she got it caught in the lathe and died from it. When you're working in wet labs, don't touch anything without being told to do so. There's a lot of chemicals besides the ones that we're using, so don't just walk up and touch something or start sniffing chemicals in the lab. Okay, so those are all the dangers, warnings, and cautions that are mentioned in the book. Be sure to watch the introductory safety video. Those are the ones that are going to be the most relevant to you in the STEM clubs.